Hello everyone, my name is Kishan and welcome to today's video on Introduction to Normalization. This is going to be a series of videos on normalization where we'll be talking about what normalization is and the different type of normalization that is available. So let's start with what normalization is. So basically normalization is the process to reduce data redundancy and improve data integrity. So once we have created say a table, what all we can do with it? We would insert data into it, we would then update that data, and as time progresses we would delete some data as well, right? So let's take an example where the database is denormalized or in a way not normalized, and then what all issues we would get while we are trying to insert, update or delete any data. So we'll talk about insertion anomaly, update anomaly and deletion anomaly. So say suppose this is a table where it holds the information about the faculty and it has the faculty ID, the faculty name, when the faculty was hired, and the course that the faculty teaches. So if you see the first record, faculty ID is 100. The faculty name is Dr. Desai. He was hired in 11th February 1991, and then he teaches physics, introduction to physics, so physics 101. Similarly, you have Dr. Mehta, hired on 19 June 1990, and he teaches chemistry 101 and chemistry 201. Now, say suppose if the question is that enroll a new faculty member, Dr. Paul. So say you want to insert his information. So he has just joined, Dr. Paul, and now you want to fill this information. So say you create a new faculty ID for him, 102, you have his name, Dr. Paul, and then you insert his hire date, that is say 21st December 2000. But he's not yet assigned any course. Say suppose he has just joined and he has not yet picked up any course that he is going to teach. In that case, what would be under course code? You could always enter null, but yeah, you got that idea, right? So this is an example of insertion anomaly where you don't have everything that you need. Ideally the course should be in a separate table altogether so that you could easily create faculty records, and then as time comes you could also create course records. So this was an example of insertion anomaly. Now let's move on to update anomaly. So say suppose this is a table where you have employee information. So you have employee ID, employee's address and employee skill. Now say suppose the question is that update the address for employee ID. So the first thing that comes to mind is you just write an update query, update table name set address is equal to the new address where employee ID is 101, and both of these records will get updated. Now with new age databases like MySQL and Oracle and SQL Server, updating multiple records is not a problem. But think it logically, you are only updating one entity, right? You are just updating the address of one employee. Why should it go and update multiple records? Ideally this is a bad design. It should have gone at one place and updated that one record, but here it has to update multiple records. What this could lead to is, if the update query is not written properly or with any other reason, you could end up with inconsistent data. So you could end up updating one record and the one other record is still pointing to the old address. Now if this happens, your database basically will not be able to answer the question what is the address of employee ID 101. Now let's talk about deletion anomaly. So basically let's take the older example that we had of the faculty, and over here if the question is that remove course code physics 101, the institute decides that they are not going to teach physics anymore. In that case, what you do is you just want to remove this course code 101, physics 101. But what happens is you would write a delete query, right? Delete from table where course code is equal to phy101. But when you do this, you end up basically removing the whole faculty information of Dr. Desai. So if someone comes tomorrow and says, when was Dr. Desai hired, you basically don't have him in the record. You just deleted that whole thing. So this is an example of deletion anomaly. So what we want to do with normalization is we want to avoid these anomalies. We want to design our table in such a way that we don't face such situations. So fully normalized database allows its structure to be extended to accommodate new type of data without changing existing structure too much. There are few rules for this database normalization, and each rule is called a normal form. So you have various normal forms, 1NF, 2NF. So that basically means first normal form, second normal form. Now, practically, the third normal form is considered the highest level necessary for most applications. But then we have special cases as well where all these different type of normal forms are implemented. So in the next video, we'll start with what first normal form is and what all rules should be followed to get your database into 1NF. Thank you for watching this video. I hope you learned something new today. Please do let me know your thoughts in the comments. This is Kishan signing off. Thank you.